All right, C495. All right, so let's move on. We just finished 3 model and comparison in the chart. So current model is M3. We have outrigger truss on 2 elevation. So here you could see that elevation B and elevation, is that D? No, yeah, elevation E. So we add the 2 elevations, right? You see that the yellow color, we had the a pair of outrigger truss. Now, what I want to point out in this model, since we add the outrigger truss, diagonal truss, what we need to watch out is this column load takedown. The current model is just the one, the complete model. The building was constructed and all the load, design loads, especially gravity loads, are assigned at the same time, which it creates some, this is situation. So the column actual load coming down, right? But the column reaction is reduced. The reason why, because the bracing members are holding up. So this is not the good conditions. If we use the M3 model for column design, right, the dead load cases, all gravity load should be underestimate the column reactions, column action forces. So these cases, we should run the construction sequence analysis so that during the construction, we ignore or skip the full connection of this bracing. When we erect, that we temporarily connect or didn't make any connections, so that this bracing is not fully installed when the building is top out. When the building is top out, which is constructed all the way up, and we come down and make the permanent connection between the bracing and column, so that all the column reactions should gradually increase during the construction, right? After construction is topped out, is completed, we tie together. So the subsequent loading, SDL and live load, all the wind load should develop based upon with the full bracing engagement. So here, what I want to show you here, I already set it up auto construction sequence cases, but I'm gonna turn up that if your team has end up with this bracing, you need to follow along. What you need to do is, first of all, you need to, let's say here, bracing, grab the bracing, let me turn up that. Right here is a bracing. Assign those 2 bracings to outrigger, the group. So which I already added, but I'm gonna do it again. So this is maybe outrigger bracing, right? Edit, so outrigger bracing, and this bracing member, I'm gonna create the group. So let's see. Let me double check. Do I have a group? Yeah, group. Right. So I just made this group. The reason why, I'm gonna set up the construction sequence analysis. So let me just delete it. Okay. Here. Okay. So here, when you go to a define, you could go to auto construction sequence cases. You just turn that on. Only self-fade dead load you include in the scale factor. So this construction sequence analysis, I will show you graphically. The ETABS create gradually and assign the load, gravity load, dead load uh, at each construction the stage. So here we could, for fast computation, I'm gonna add every 2 floor. We're gonna build that model, but I'm gonna exclude the Outrigger bracing until the last step is completed. So this is the download, auto sequence download I'm gonna use for my column design and all the member design um, cases. So this download I'm gonna replace with the typical our previous download type, and let's see. Okay, so model ran. The what I'm gonna show you here, actual force. The previous download case is what you saw. It generates some the the tension forces. The bracing is contributed, and which actually resulted in the favorable column reaction here in this model. Instead, we try to use auto sequence download, and then I'll show you. So you see that this is construction sequence. So it's a build every 2 floor, and then that load self-weight is assigned. So as the move on to the next step, it the model will build every 2 floor, since I set up at 2 floor, and I skip the bracing and keep going up. So actual force continuously grow, increase. And when my model is top out, you see that all column reaction actual force is continuously increased. In the last stage, I add this bracing, right? Oh, here, auto sequence. So, so the auto sequence stays at 20. So this we build up entire building all the way up to the roof, and this generate all this low takedown actual force on the columns. So this is auto sequence download. We need to use it for entire column design. So all right, so after that we need to make sure our load combinations, maybe I can remove it just in case. And so in default, I'm gonna create the steel frame design, and S series we should have auto sequence, right? So this is auto sequence download we're gonna use instead of previous the download. So all here in ultimate load combination for download, we need to use auto sequence download. You need to check it all this. All right, so I think that this model, it seems the completed and ready for final design. Maybe I'll choose design still, and the load combinations I'm gonna use S series. And I'm gonna run the model and see all the members are working. Okay, the steel member check is completed. I'm gonna show you the elevations. See the columns, seems okay. I'm gonna show designs PM interactions. So the outrigger column is usually selected for the stiffness, so stress level is pretty quite low. And the bracing we chose is slightly overstressed, so we may have to increase a little bit. And you see the column, the section continues to reduce, and stress level is slightly varies. The one thing I need to show you, since we have a steel diaphragm here, this beam doesn't take any actual load, but we need to release the diaphragm here, and we should run the model again. So I'm gonna unlock and check the 20 and 22. Maybe I'm gonna discontinue the diaphragm here, right? I'm gonna discontinue this column, and also goes down. Maybe discontinue, and story 20, discontinue. Okay, so I'm gonna use this model and rerun it. All right, so the analysis is done. Let's check the elevation B, right? Instead of run the all entire, I want to just select and run this elevation. So about a minute, 2022. All right. The one thing I forgot to tell you, so this is actually diaphragm. I released the diaphragm, but also when you check this, because it was assigned as the frame design composite beam previously, so we need to change the frame design procedure to steel frame design. So when you select it, and ETABS will run design check. Let's see the stress level. Okay, so stress level, yeah, this bottom core is okay. The diagonal we need to increase a little bit, and top core seems like we need to increase the size a little bit as well. So I think again, this is now column and bracing and some truss. Some of those member we should run with a steel frame design, so that we need to specify those member to follow the steel frame design procedure, so the ETABS will recognize these members run for the steel design. Okay. All right, so let's see. So I think for this example, maybe we need to increase these sizes. If you have some, if your model, okay, this one seems okay, 0.9, 0.96, or I can increase the step one more up, or this beam I can increase the size a little bit, but for now I'll stop it for example purpose. And what I'm gonna show you is again the material tonnage. Assume that all the tower member size is complete. You need to pull out just material takeoff here. So you could pull it out. You could sum them up all total column. Actually, I need to select all. Okay, select only member was checked. So here you can see that column steel tonnage is 2400 kips. beam 3000, right? Other beam is concrete beam, steel bracing, steel tonnage. The wall is more concrete, so that you could pull it out, and so you can bring this one out here, that you could organize, let's say bracing should be here. Oops. So you can organize per steel and concrete. So based upon this, right, so we end up with 5800 kips, which is divided by 2, so we have 2900 tons of steel we needed. And bracing I already. And for the concrete, this is all concrete beam and wall. I sum them up, this is all kips. So this one I divide by 150, right? Is pounds. So, but multiply by 1000, divide by 150. So this is a cubic feet. So that this one divided by, let's say 27, is cubic yard. So you could calculate the total. You could sum them up the weight first and divide by your unit weight, right? And you should be able to calculate the volume of the concrete. Cubic, also we typically use cubic yard as well. All right, so I think this is something you need to, once your member design is complete, you could pull it out the material takeoff and summarize it. First, for the steel, you need to use a ton, and for the concrete, you need to use the volume. Okay, so I'm gonna close here. So tomorrow we're gonna talk about also foundation system as well. Okay.